Thanks for joining me. This lab session is entitled JMeter Performance Report Analysis Lab Part 2. I have more to share on test scripts, more on the workbook, and more on test results and findings. You probably observed on the response time sheet that there are no results for endurance and stress testing. That is because, though it is a part of the test project plan, I need to leave something for you to do. That is, if you want something to do to enhance your skill level with JMeter. Another reason I decided to stop the project at this point is the risk of boring you with so much detail. I'm open to your comments though. However, let me share one more reason for stopping with what I have. As you look at the data I do have, you should come to a similar conclusion I did. Further testing may only serve to conclude that the testing should move to a server configured with faster processors, more core, and a database manager. I believe what you've seen so far, along with what I am going to show you, should be sufficient to appreciate the power of JMeter and its reporting capabilities. Moving from the baseline test script to the load test script, there is, first of all, a major change that occurred, and that is in the use of thread groups. So as you can see here, we have a concurrency thread group used for the login, logout, and for the rest of the functions, we have the ultimate thread group. With that thread group, I'm able to do things with a little bit more flexibility, departing from the regular thread group. So if we look at the first one, you saw that one before, and basically we're still in line with the target concurrency, so those number of users that are going to log in and process the function, we stuck with that. That's important. But we changed ramp up and potentially ramp up step. Mostly 30, 10, and then we hold the process for 30 seconds. And that simply means that instead of it being just the 22 user processes of the function, it potentially could be 100 more, depending on how long this process takes for each function. It needs to keep, for 30 seconds, keep a concurrency of 22 users. So that forces it to create more, forces JMeter to create more iterations of that function. Now, looking at the others, we're using the ultimate thread group. It's still similar, and on the, the step, this one, whoops, you can see here, if we had 0 startup, then there would be no step. It would just immediately run whatever number of thread count you have. By doing the 10, we turn that into a step approach, not as aggressive as going immediate, all users starting up at one time. And so we did this similar thing for each one, and I remind you that we held at 30 on each of these, so that's this straight line here. For that amount of time, we forced X number of users to be running the function. Same thing, same thing. You'll notice the startup changed a little bit just to change how the use, so that all the users that were logging in were not logging in at exactly the same time. So by changing that number a little bit, we make that happen. All right, let's take a look at the stress test. And we still again have the login like it was, with the exception that you see where the numbers were increased. Instead of 30, actually, I think it was like 10 for the step up and 30 for the ramp up. It was increased this way, 60 steps along with 60 ramp up, or 60-second ramp up, if you will. Now, on the ultimate thread groups for the rest of the functions that we were using in the test, we change the hold was removed and potentially changed the delay to almost no delay or no delay. I believe I may have done that on, let's see. No, I have 5 instead of 10, and 60 on the startup time, but no hold. So it's just the idea of ramping up the users, getting them to get started. But there was one additional thing that changed with the stress test inside each thread group. I'll give you an example, well, with the exception of the first two. I'll give you an example here. There's a loop controller that is encapsulating the function. By doing that, we can control how many times or iterations of that function execution. So each user, in essence, now with this approach, they will run the function 5 times. Each function would run each user 5 consecutive times. So that creates more traffic after the user logs in. It doesn't create more login traffic, it just creates more user traffic requesting the function to run more than once. So that helps with creating what we call a stressful condition. Okay, I think that explains that. I don't need to go through the rest of them. Also notice that I was running without the flight change and itinerary C. Everything else is there. So that was just because of what I chose. And when we get back to the workbook, you'll see what I'm talking about on that, why I did that. Alrighty, that's it for that part. When I come back, we're going to talk about more about the workbook and all the rest of the worksheets that are there. Okay, we're looking at the workbook now. We've talked about some of the sheets like the load and the workload and the requirements. Those, I believe we've talked sufficiently about them. But let's start with the test schedule, and then we'll go to some of the others to complete the discussion on those topics. So with the schedule, the test schedule, we had a plan for running some of the tests, not all of them. And that's the reason for the highlighting. We ran the baseline test. We actually ran it for all of the functions. Then we ran the log in, log out load test. We were going to run another one, a complete one. I'm sorry, and we did. We ran this test by itself, and then we ran a full function test. So that's as if we had reached release 7. Remember, I told you we had a little flexibility there because of the fact that I do have a fully working version of the application. So rather than treating it like, well, we'll just run this, I ran all of the functions that were available. Then the idea was to run a stress test, which I did, run it as if we were at release 5. And the plan was to run an endurance test as if we were at release 6. And then finally, another endurance test with spikes as if we were at release 7. Instead, what we're doing is I'm not running the endurance tests. We ran actually the baseline, load test, and stress test. And we're trying to draw some conclusions. We have some recommendations as well as observations on what occurred up to the stress test. And we actually ran 2 load tests and 2 stress tests just to get enough information to report on. Now, before we get to those reports, let's talk about the test design. Want to make sure that everyone understands what we were doing so far. This is a set of charts that you may see out on the internet that will give you a feel for what should excuse me, a test look like. We have a picture for a load test, a picture for a stress, endurance, and endurance with spike. So we were saying we're going to run load tests. We did that. We were saying we're going to run a stress test. We did that. The stress test didn't look exactly like this because we did a step-up approach so that it wouldn't be as stressful. So that worked out. And the endurance test would look more like a straight line on a horizontal bar, where you basically are targeting some particular concurrency and you just stay with that for some period of time, typically 2, 3, 4, 8 hours, whatever you think is necessary. And what you're really looking for is to find out if is any kind of memory leak issues, any kind of processes that seem to be stuck and still running as soon as it's engaged. And then the other endurance test with spikes looks like this, where you have these sudden movement into high concurrencies, and the response times typically get challenged there. We see higher response times. So typically we should see that. Sometimes that might not happen. But we do attempt to go from the endurance flat line to something that shows that there's suddenly some activities. Sometimes an application will do that without you trying to make that happen. And those are some bottlenecks that you'll tend to have to look into further as you proceed through the test project. All right, so that should give you an idea of what you're looking for when you're setting up your test, especially in JMeter, because using a couple of those thread groups, the ultimate thread group as an example, you can create something that looks like these. So, just wanted to make sure that you had that kind of information to draw from. Now, let's go to the response times, and then after that, we finish talking there, I want to go to the observations, recommendations, and conclusions. And then there's one more, the topology. Why don't I do that? Before we go to the response times, let me talk briefly from this topology. And what I'm trying to show here is, first of all, this row 2, column B laptop. That's what I'm running these tests. Basically, that's the topology I have. I'm not going out to any servers on the internet. Everything is running locally on the laptop. That is not the ideal environment to test in, because you have the application and the load test tool, such as JMeter, running on the same machine. That's not a good combination. And that's one of the reasons why we kind of came to the conclusion I did. Okay? But it doesn't mean you can't do it. We're doing it to actually get some demonstration of some of the things we've been talking about. What we want, which is more ideal, is this kind of topology where we have a true web server, app server, and database server. And they're not all running on the same machine. They could be running on the same machine, and that wouldn't be so bad if the server, the hardware itself, is robust enough. But typically, you want each one to be on its own hardware. So that's a good configuration. But when you have a multitude of users, 10,000, 100,000, 1,000,000 users running against an application, then you want to think about a different topology where you have what they call load balancers that help direct the traffic to one or more web servers, one or more database servers, and one or more app servers. So this becomes a much more complex topology, but it exists for a number of different well-known applications. And finally, if we compared a server to my laptop, here's what you're looking at. I have a 2.2 gigahertz, 2 CPUs, it's dual core, and 16 gigabytes of RAM and 1 terabyte of disk space. And it's a SSD. On the other side, a server, one that would provide maybe 10 times as much power as my laptop, would be a server that doesn't have to use a much stronger gigahertz or processing power. 2.4 is good with 2 or more of them. But this is where things get far better, is having a significant number of cores. Where I only have 2, the servers can have 12, even 16 cores. And that gives a lot more processing power. Then, of course, the memory doesn't have to be as much memory as I have. 4 gigabytes is plenty. And then the data space typically is going to be much larger than a terabyte. So that wouldn't be a bad move from the laptop to a single server running the same application. But however, I do suggest that rather than it being flat file processing for the data store, that it be a true database server. And that would allow for more tuning to take place. Same thing with the app server, same thing with the web server, to allow for better tuning, better separation of functionality, so that each server can function at its best. All right, let's move back to the response time. On the response time, I just want to make sure you understand what I have here. I have the baseline test results, just looking at the response times and throughput and network information. Same thing with the load test results. And down at the bottom, I have 2 reports, basically, of stress tests. So the stress 1 test results and the stress 2 test results. Let me talk a little bit more about that. One of the things that I experienced with the first round of tests was a single error. See it in this column right here, highlighted. Internal server error occurred. And that actually, there seems to be a root cause of an insufficient Apache web threads. Apache, I'll talk a little bit more about that, but Apache defaults to 64 threads that it opens when you start up the web environment. And we exceeded that during this test. And so that ended up with a internal server error. It could no longer respond. So that was my final comment here, is Apache stopped responding. So it did not process all the functionality or all the functions to its completion. And you can see that with a login of 102 users, but a log off of only 32 users. So some of these functions did not complete successfully. Now, that doesn't mean that you see all kinds of errors here. You see the errors mainly is showing up on the login. So not even all of the logins, the users that were trying to log in, were not able to completely successfully log in. Even though functions were not able also to complete, there were no error conditions created. It just stopped functioning. Excuse me. So we ended up with 419 samples when we look at just these functions, not this welcome page or the total. So that was not all of what should have run for that test. Consequently, the test average response times got into multiple seconds to run. And as you noticed on the loads, it did a similar thing there, but on the baseline, much lower. So there was a significant increase on the load test as well as on the stress test. But the load test managed to process a few more. And there was no errors whatsoever, even with login. So even though you can still see that the login count was 183, whereas the log off was 97. It still didn't show any problems or errors that were critical. So it managed to accomplish more during the load test, more samples completed than with the stress test. So the stress test definitely was showing that it was in a stressful condition for some reason. And it ultimately stopped responding, the web environment. In the second one, it looks like the app stopped responding before the web services stopped responding. So that indicates it was even more stressful. And I mentioned two things here. These were changes that were made from the first stress test. We decreased the ramp time and added that loop process for some of the functions. And still, they were not able to complete as much as on the first stress test. So we only had a total of 400 samples that completed versus 419. Excuse me again. And these response times definitely increased over the first test. They were longer here than here. Now, what I did too was I took those, to make it easier on the eyes, I created this other little chart here to show the response times in comparison. So we have the baseline, the load, and the stress. Now, this is the stress from the first stress run. Yeah, 2121. Okay. I probably should have put the second one, but that's okay. This still tells the story that when you look at the baseline, that baseline in comparison to the load itself is marked difference. You're seeing a large percentage increase from baseline to load. You could see less than a second to 7 seconds, or almost 8 seconds. And you can also see from the comparing the load to the stress that the stress is less than the load. But the load was much more successful in the test because it wasn't under stress, where this test was under stress, and that tells you you would have expected that it would have been even greater numbers. But because all of the processes were not able to complete, we again see low numbers, but higher than the baseline. So we definitely got into a stressful condition under both of the stress tests. Excuse me. And we're going to look at the reports that will help us to understand what happened. Now, one last thing before I move on, and I put this little chart together to show the traffic for baseline, and I estimated this line, and we have the load test and load test 2. I didn't add the stress in this one. So we're saying that with 7 users, the response time was half a second, where as we moved on to more and more users, we see an increase of slight increase for the login. For 100 users, doubled the increase for 185 users, and then for 434 users in that load 2, we ended up going into 5-second response time. So there's definitely impacts that are occurring as more and more users are in the system trying to make requests on the application. Now, let's look at a little bit more reporting that tells us more of the story. So, we created these three, and typically when I do a performance test, I'm looking to use these three reports as a tool input to the final report to the stakeholders. So the observations report looks like this. The recommendations looks similar, only it can refer back to the observation or refer forward to the conclusions. And then the conclusion can also point back to the recommendations or observations. And that is if we start with the observations having some recommendation or some conclusion related to that item. So try to have a sort of coverage analysis between the three sets of data. But we start with the observations, and I mentioned this before, but it's worth mentioning again. The observations are typically things we observed during the testing, whatever test phase we're in, but we're not sure there's anything we can prove. It's mostly just trying to document what seemed to have happened or what we think happened. Then when we get to recommendations, we're talking about some follow-up that needs to occur, and hopefully we can draw some kind of conclusion to that recommended or recommendation that we're following up on. Okay, so go back to the observations, and we have written here so far 8 observations. I'm not going to go into detail. I'll give you a little chance to read some of it yourself. I want to point out, here's one that we did talk about a little bit. During the stress test failures, internal server error occurred at 38 requests per second. This is the user demand rate, which reached 70 requests per second. Some functions were able to complete at up to 70 requests per second, but not all. We definitely had a situation where it did not complete. Now, if we go to the recommendations and look at the fourth one, that's related to that, and we're saying collect perfmon data for another test run. And I did that. And so, because I did that for observation 6, and this is requirement 4, we have a Charlie 1 or conclusion. And in the conclusion, I state something. During the last stress test, perfmon data was collected. Inbound TCP requests were at 27 per second, while the outbound TCP traffic was at 44 per second. This was measured on port 1080. This is the port that the application was processing on. The application was not able to respond as fast as requests were received. So, that is the conclusion, and that helps with some of the other conditions also, but we haven't pointed that out. And we have another conclusion here in that perfmon report did not confirm high I/O activity. That was one of my concerns in the observations, that observation R3, if I go back to that, it said at over 400 concurrent user traffic, response time increased over 1,200%. Excuse me. So that was something to then turn into a recommendation, which was R1. And at R1, the information stated, if user traffic growth expected to increase within the year, a server is needed. So there's a recommendation. No follow-up is done on that, but that's where I started to get the idea that, well, it probably would be better to get off of the laptop with this application for further performance testing and go to a server that would give us much better throughput, and the response times would obviously go down significantly. So that would address multiple issues we were seeing. Again, the observations are simply trying to communicate some problems that were seen, or something that was good that we maybe weren't expecting. One of the things was this one down here. This was a much lengthier observation, but it was basically about looking at the error log for Apache, the web server, finding out that it had a default of 64 threads to handle concurrent processing. And here we are trying to do concurrent processing in the performance test, and we hit that threshold. And so the server then became unresponsive. It's good that it's still, the computer itself, the laptop, was still able to complete the test run without it freezing up. But these are the kinds of things that you are going to have happen with trying to performance test on a laptop, because it's going to potentially cause that laptop to come to a frozen state. So you have to be careful. That's a risk that you would have with using an environment, a computer machine that is not able to handle some of the thresholds it could reach. My time has ended for this session. I thank you for yours. Join me in the next video.